So we speak today with someone whose work is credited with preventing 400,000 cases of blindness and saving as many as 1 million deaths per year. Dr. Alfred Sommer has earned this place in global history. He discovered that vitamin A deficiency reduces immune responsiveness and resistance to infectious diseases such as diarrhea and measles. He proved that vaccination for smallpox, as late as 6 days after infection, can prevent the disease. He demonstrated the effectiveness of a simple and effective tool for monitoring the nutritional health of children at high risk of dying from malnutrition. And he identified an early, accurate predictor of optic nerve damage, signaling when to start glaucoma therapy. These are but some of Al Sommer's accomplishments. I'm Kelly Brownell, Director of the World Food Policy Center at Duke University and Professor of Public Policy at Duke. Al Sommer is a professor of epidemiology, ophthalmology, and international health at Johns Hopkins University and is Dean Emeritus of the Johns Hopkins Bloomberg School of Public Health. He is a member of both the National Academy of Sciences and the National Academy of Medicine. His research focuses on child survival and blindness prevention strategies, on micronutrient interventions, and on the interface between public health and clinical medicine. For his contributions to global health, he has received many awards, including the Albert Lasker Award for Clinical Medicine, the Danone International Prize for Nutrition, among others. Al, I followed your work for many years and remain impressed by how someone who has so accomplished so much can be such a nice and humble person. Thank you so much for joining us.
Oh, you're too generous.
So you've done groundbreaking work, as I mentioned already, on vitamin A that has saved many millions of lives in developing countries. And I'd like to relive some of the steps you took in this discovery process. But first, can you explain the problems caused by vitamin A deficiency?
Well, what we knew for years was that if you made animals, or we had observational data back in the late 1800s, early 1900s, when children particularly become vitamin A deficient, then they develop a sequence of issues, and we were forever focused on the eye. And so the earliest manifestation is a child can't see after sunset. So they suffer from what's called night blindness. More severe deficiency causes keratinization, cornification of the outside of the conjunctiva of the eye, the white part of the eye, and then ultimately of the cornea, the clear part where you actually see through. And with severe deficiency, then that cornea can ulcerate and melt and entirely disappear, and you lose the eye within the course of a few minutes. What we now know, and we didn't know when I first got into this game, was that in fact, the eye signs are not the earliest manifestations. The earliest manifestations, in fact, are so prosaic that people hadn't identified them with vitamin A deficiency, and that was, as you've already pointed out, Kelly, a diminution in the immune responsiveness, which means that children at risk when they are infected with diarrhea or pneumonia or measles have much less ability to fight off the infection, and therefore they have a much more severe clinical response and a much higher mortality rate.
Oh, Al, when you started the work on this issue, what was the extent of the problem and where in the world was it most severe?
Well, the earliest studies, probably because that's where the clinicians were attuned, were actually from Europe and Japan. And that would be at the turn of the 1900s. By the time I got involved, because an agency in New York that was starting a blindness prevention program thought it might be an important issue, was in the early 1970s. And that was primarily on the basis of a very informal, quote, survey that was undertaken at WHO's behest back in the 50s by three giants in nutrition and ophthalmology, Don McLaren, Oman, and Esposito, who basically broke up the world. They each visited about 5 countries, talked to pediatricians and ophthalmologists, and asked about seeing these eye conditions, because that's what people were focused on, and did they tend to see it in the hospital? And often they were told, yes, we do in the diarrheal ward or the malnutrition ward. We will still see children who have either problems with night blindness or, more critically, have actually gone blind because of melting of their cornea. So there was a feeling that in the developing world, broadly, there were manifestations of deficiency, but nobody really knew how great the extent was, where it was most severe, who were the children who got it, and why did some children get it and other children didn't get it, and what could be done about it. And that's when I entered the picture and was asked for some assistance. And being someone who always asks questions before they dive in, I said, well, do we have any sense of how severe it is and where one might find it? And at the time, I was a resident in ophthalmology, so I couldn't go very far away from Baltimore. And so we picked first one country, El Salvador, then Haiti, where we actually conducted a randomized survey in the rural areas looking for the disease, where we would find it, how severe it was, developed manifestations that became WHO criteria for how frequently or how prevalent are these various manifestations, and in order to qualify for being a vitamin A deficiency as a, quote, public health problem. And we looked at the registries and the hospitals to see what they had recorded. And those showed that, in fact, it was much more extensive in those two countries than anybody had previously thought. And that led me to write a manual for WHO on what are the ocular manifestations of vitamin A deficiency, how to diagnose them, what are the criteria for public health problem, and methodologically how to go about carrying out a simple representative survey in the population. And so that would have been the early 1970s. And that led me again to say, well, it looks pretty prevalent in these two places we've looked. Now we need to know more about whether or not, why some children get it and other children don't get it, why some are more severe than others, and what can we do about it, which led me to put in a proposal that got funded and that moved to Indonesia for 3 years, where there was reasonable hospital-based evidence that there was a serious problem. And I could answer, as I then depicted it, all the questions I would like to have answered before one can go about mounting some sort of an intervention program.
So this first step was to document the relationship, but well, that had been done earlier about between vitamin A deficiency and these serious physical conditions, and then you established the extent of the problem. What was the next step?
But so when I went to Indonesia, there were I carried out 3 critical studies. One of them was essentially to examine everybody who came to the hospital with the eye signs, because that's what we were focused on. Historically, that's what vitamin A deficiency was all about, primarily because that was unique to vitamin A deficiency. So I studied everybody that came in. We also carried out studies where we followed 6,000 children in 6 villages, examining them every 3 months. That study, for 18 months, that study was conducted with the thesis, well, why do some children get severe vitamin A deficiency and children living in the same village don't? And then the third study, major study, was a countrywide survey in order to document for Indonesia where the disease was most prevalent and how severe might it be. Now, some of those studies yielded data that we hadn't anticipated. So the one in which I examined all the children coming into the hospital, a lot of them came in for night blindness. That was simple. Our recommendation, which had been established by the World Health Organization on a committee that I sat on only a couple of years previously, was that could be treated with oral large dose vitamin A. But a child who had more severe disease, early ulcers or cornification of the keratinization of the cornea, they needed emergency intramuscular water miscible vitamin A injections. Now, the problem with that was that nobody made water miscible vitamin A. Vitamin A is an oil soluble vitamin, and around the world you could find injectable vitamin A, but it was all in oil. And one of the things we had discovered in reviewing the literature for this WHO technical committee a couple of years previously is that in rat experiments, if you inject a dose of oil miscible vitamin A subcutaneously or intramuscularly in a rat or in a child, you don't impact the vitamin A status at all. It just sits there like a lump. So sitting in a WHO room, we came up with the recommendation based upon animal experiments that really, if you want it to be absorbed rapidly, that intramuscular injection has to be a water-miscible preparation. That would be like homogenized milk. So the fat is dispersed within the quart of milk and doesn't come up to the top as cream. I get to Indonesia. The first child presents with actually a corneal ulcer, so that's a real emergency. I turn to my Indonesian colleagues and I say, get me some water-miscible vitamin A for injection. They looked at me like I was crazy, which I was, because they had none. In fact, nobody had any. Despite the WHO recommendation, nobody had told the pharmaceutical industry to prepare injectable water-miscible vitamin A. So I was stuck initially without our recommended treatment. I knew that if I injected the oil-miscible vitamin A intramuscularly, it wasn't going to have any impact. But I did remember some animal experiments in which when they gave the oily vitamin A to rats by mouth, it actually worked pretty quickly. So I got the injectable water-miscible vitamin A, sucked it up into a syringe, took off the needle, and then squirted it into the children's mouth. Right after doing that first child, I then telexed colleagues at Roche and asked them if they would produce some water-miscible injectable vitamin A. And of course, they were happy to do it, but they said it's going to be 3 or 4 months. By the time they formulate it, they do toxicity testing, they get permission from the Indonesian government and license to import it. So I was treating every child that came in for the next 3 or 4 months with this water-miscible oral, with this oil-miscible old injectable stuff, but putting it into their mouth instead of injecting it. And they seemed to respond very rapidly. When I eventually got the water-miscible injectable version, I decided, given this old stuff orally seems to work very well, let's set up a randomized trial in which half the children who presented with corneal ulcers were given the old-fashioned oil-miscible vitamin A by mouth, and the other half were randomized to get the new water-miscible vitamin A by injection. And in the end of 2 months, we had done about 60 or 70 children, and their biochemical response and their clinical response was absolutely identical. Now, why this was critical, it took 5 to 10 years to convince my colleagues. Nobody else ever replicated this trial or attempted to replicate the trial, but nobody wanted to take away the injectable water-miscible vitamin A, even though it was very hard to get. And it took 5 to 10 years. Originally, I argued enough that we could get as an asterisk, if you don't have water-miscible vitamin A for injection, give oily vitamin A by mouth. It took 5 to 10 years before we could get them to move that up as the primary recommendation because it's so much safer. Anybody can do it. You don't need a healthcare worker to inject it. And that, therefore, paved the way for what became these large-scale programs for distributing high-dose vitamin A, supplementation programs, because you did not have to do it by injection. You could do it by mouth by simply giving a small capsule or an equal amount in a spoon.
So let's talk about the large-scale expansion of the work you did, because one challenge, of course, in making initial public health discoveries is scaling things up so that they can work for hundreds, thousands, or millions of people. So how did you address this issue?
So yeah, I was, again, fortunate. The head of UNICEF, while I was doing this work, was famously Jim Grant, who was probably the most effective UNICEF Director General there was. The person who is his chief medical advisor was following my work on vitamin A and would periodically ask me to come into the office in New York and brief Jim on what we were doing and what we were finding. So I had a colleague who is in charge of, the largest agency that had to do with the health of children, who is interested in seeing whether or not this, in fact, was necessary and whether or not it was effective. I also knew Nakajima at WHO, and he too got interested in whether or not this would be effective. Now, I have to say, so that put me in a well-placed in order to try and make the argument. I'm not sure it would have flown if it remained totally focused on blindness, because there weren't a lot of global health champions who are interested in spending money and resources on preventing blindness. But it was soon after that that I made this unexpected insight that from that original study where we were following these 6,000 children, that the children who had early mild, quote, early mild vitamin A deficiency, just night blindness, the earliest ophthalmic clinical manifestation, that they were dying at much higher rates than the children who had no eye signs at all and had slightly better vitamin A status. So that led us to do several randomized trials that demonstrated convincingly that distributing vitamin A large dose capsules reduced the childhood mortality by about a third. Now, again, nobody believed that either early on. So we had to replicate it. We got other people to replicate it. By 1992, and this I think was critical, still there were people arguing on both sides. Nobody actually had negative data. They just couldn't believe that 2 cents worth of vitamin A could reduce child mortality by a third.
That's staggering,
Yeah,
staggering impact, isn't it?
So in 1992, these commentaries are still going back and forth. People are still debating. And I said, this is ridiculous already. We were already 6 or 7 randomized trials. And these are trials with 20,000 children. These are expensive, difficult to do trials in 4 different countries. And so I called a meeting at the Rockefeller Retreat in Bellagio. In those days, you could only have about 20, 22 people who have been involved in these trials, people who were experts in child survival. And to make a long story short, we said, we're just going to answer 2 questions. Is vitamin A deficiency bad for children? And if we improve their vitamin A status with these large dose supplements, which have essentially no side effects whatsoever, will we reduce childhood mortality? And after going through all the data over an entire week, on Friday morning, everyone agreed that yes, it would. And I said, okay. And I went to a side room. I wrote up a paragraph that said, these are our conclusions from reviewing the data in detail collectively. Got everyone to sign it in blood, and then asked everybody at the meeting when they went back home, because this was an international meeting, if they would publish their perspective of the results of this meeting in their favorite medical journal. So I published one in the Lancet, somebody published one in the British Journal of Ophthalmology, somebody published one in the Medical Journal of South Africa. And so within a few months, people who were respected in child survival, nutrition, pediatric area sort of swamped the medical literature with agreeing that, in fact, this was a important potential program that could, in fact, be effective. And one of my concerns had always been, would the right children get the supplement, or would only the healthier children get it? But it turned out in these trials that, of course, they got it pretty well across the board. That led Jim Grant and Nakajima to host a major meeting to inaugurate childhood supplementation. UNICEF and I would go to Congress every year, particularly very supportive, existed at that time, the House Committee on Hunger, and report what the research had shown and talk about the implications for child survival if we could, in fact, get out this distribution. So Congress would allocate funds each year for these programs. And very importantly, the Canadians took a and still retain a leadership role in making these vitamin A supplements available to countries. And these are now given out in over 50 countries around the world, probably reaching maybe about 60 or 70% of the children who need it. But again, I think what made it move forward was firstly, being able to demonstrate that this impacted on child survival. And this was back in the 80s and 90s when child survival was something that was on the top of the international health agenda. And everyone had these various programs from growth monitoring onward to improve child survival and reduce child mortality. So it hit at the right time on an issue that everybody was concerned about. I was fortunate to have engaged 2 critically influential people, the Director Generals of UNICEF and WHO, who followed the work through the research phase and saw the results come out positive repeatedly, and then bringing everything together and getting a general consensus that this is an important thing to do. So it's in some ways, it was a very fortuitous series of events that came together that made this program move forward on a global scale.
Now, once you made the discovery that supplementation could have such profound effects, I'm imagining that whether these programs got implemented within countries had a lot to do with political issues and things like that that go beyond the science. Is that true? And how did you navigate those things?
Yeah, no, that's of course true. One of the advantages and one of the hangups at the same time was every country wanted to have their own randomized trial. And people did raise the issue of, is it ethical to do any more of these randomized trials after you've done one, two, or three, and every one of them gives you a 35% reduction in mortality? How can you randomize children to a placebo? And the argument I could make early on, well, if we don't do this trial, the country is not going to launch a program, a nationwide program. And when we do the trial, at least half the children get vitamin A. The other half who survive are going to get vitamin A at the end of the trial, since we're ethically compelled to do that. And hopefully it'll cause the country to change policy. By the time we had 7 or 8 trials, I couldn't even live with that argument anymore. And that's why we had the Bellagio meeting. And I just said, we have to do this. And then, of course, I would go and visit with the Minister of Health of dozens of countries, one by one, sometimes regional meetings, to present the data and talk about the impact it would have in their particular country, given their infant mortality rates and child survival rates. And it wasn't too slow a process once we had gotten through that Bellagio brief and WHO and UNICEF jumped on. One of the critical things, and I remember I was making a visit to East Africa for an entirely different reason, to set up some other studies. And I had to stop in Nairobi and met the person who picked me up at the airport, happened to be the regional advisor for nutrition. And Adam, as he's driving me into Nairobi, tells me that they just got a directive from Jim Grant that every one of the country offices for UNICEF needed to build vitamin A supplementation to the budget for the coming year. So part of the political process that helped was visiting with ministries of health, talking to the ministers, showing them the data in a relatively straightforward, simplified fashion, because they've got a million other things to do and they're not necessarily epidemiologists. But the other one was having UNICEF behind us, where Jim Grant tells the regional office to direct the countries to put vitamin A into their programming for the coming year. So again, it was a constellation of things that came together, some the science and a lot of it being the personal.
Well, it is such an impressive story and incredibly impressive results that you and people that you've worked with have produced. So I really appreciate you sharing this story. It's an interesting detective story in a way, of one thing leading to another, chasing down leads, finding out what works and what doesn't, and then thinking how to do things to scale. Very few people are able to accomplish that from beginning to end, and you have. So thank you so much for joining us, sharing that story.
Happy to have done so, Kelly. You take care.
So our guest today has been Dr. Alfred Sommer, Distinguished Scholar at Johns Hopkins University and Dean Emeritus of the Johns Hopkins Bloomberg School of Public Health. And thank you to our listeners. Please subscribe to the Leading Voices in Food at Google Play, Stitcher, Radio Public, or Apple Podcasts, or by visiting our website of the Duke World Food Policy Center. This is Kelly Brownell.